Objective 4.1, find the antiderivative, evaluate indefinite integrals, and use the basic rules of antidifferentiation. Use the initial conditions to determine an antiderivative. The antiderivative is a set of functions f of c such that big F of x plus c is the same thing as the original function. It's a way of taking the derivative of something and getting the original function back. The constant c is a constant of integration. It comes as a result of integrating. Okay. And the notation to represent the antiderivative of something is right there. Okay. And the result will give us back the original function. More generally, looks like this. When we integrate something here, it gives us the original function back here plus a constant. F of x plus c is the general form of the antiderivative. Okay. So in this first one here, they ask us to go ahead and integrate and find the antiderivative of some functions here. So I have some basic rules here for how to integrate certain types of functions. One is a power rule. One is a power here. Okay. Then we have one of the exponentials is there, and this gives us a ln function. And this is when we have a constant here. So the first one here, we have a power, x raised to a power, and r is 2. So when we write out the result of that one there, we're going to have something like r is 2. You're going to have x to the 2 plus 1 over 2 plus 1. Gives me x to the third over 3 plus c plus c. Okay. The next one we have here is 8x. We have 8x. So the first thing I do is I factor out the x here. Then I integrate it. It looks like this one here. So when I integrate it, I'm going to have something like, in this case, k is equal to 8. So I'm going to have something like 8x plus c for my answer, coming from right here. The next one is I have a power rule. So I factor out that constant and then I integrate x squared. We already did one like it. So I'm going to have 3 times x to the 2 plus 1 over 2 plus 1 plus c gives me 3x squared plus c. Okay, so we integrate that there. Oh, hold on. Fix that. Let's see if I can write this a little bit smaller, save some room here. So when I factor this out, I'm going to have 3 over x to the 2 plus 1 over the 2 plus 1. And that's going to give me 3 over 3 x to the third plus c, or just x to the third plus c. There. Next one here we have e to the x. You see there a is 1, b is 1, so I see one like it. So when I rewrite this one here, we're going to have b over a, which is just going to be 1 over 1, e to the a 1x plus c, and that's just going to be e to the x plus c. The next one, last one here, I have integral of 1 over x, and that corresponds with that one there. So I end up with ln of x plus c. Let's look at another one. So you see some more rules there. Integral for a constant. There's the power rule right there. Okay. Now it appears that it works for everything except for -1. When the r is -1, we have a special case for that, and that's when you have the log right there. And that's when you have a log. So when you have the case of 1 over x dx, or 1 over x dx here, you have ln x plus c, and that's what that last one dealt with. Okay, and then the last one here deals with the exponential, which I just worked out there. Let's look at some more examples. So in this first one, we have a power where r is 7. So what I'm going to have here is x to the, what's that, 7? Seven plus 1 over 7 plus 1 plus c is equal to 1 over 8 x to the 8th plus c. And that's what I got there, looking at that one there. The next one I have, I'm going to have x to the 99 plus 1 divided by 99 plus 1 plus c gives me 1 over 100 x to the 100 plus c. And that's a and b. And c here we have a square root. In this case here we got x to a raised to an exponent. That's not 1. Okay. So what I have here, I'm going to have x to the, wrong one, I have x to the 1/2 plus 1. Then I'm going to have, down here I'm going to have 1/2 plus 1 plus c. And that's going to become x to the 1/2, x to the 3/2 plus 3/2 on the bottom, which is 2/3. X to the 3/2 plus c. This last one on the bottom here. Okay, so I get to that point. I have x to the 3rd. That's going to be equal to x to the -3 plus 1 over -3 plus 1. This would be x to the what? -2 over -2. And since that's a minus 2 there, I end up with negative 1 over 2x squared plus c. Everybody can see that there. So that's how I got that one using the power rule. That's how I got that one using the power rule. And now I did C and D. Now for C and D, I went ahead and rewrote them. I have the 6th root of x, and rewrote that as an exponent. R is equal to 1/6. So I rewrite it. X to the 1/6 plus 1. On the bottom, I'm going to have 1/6 plus 1. And that's going to be equal to x 1/6 plus 1. They'll be equal to x to the 7/6. Then I'm going to have 7/6 on the bottom. So my final answer is going to be 6/7 times the 6th root of x to the 7th plus c. This next one here, we have 1 over x to the 4th. We have an exponent r is equal to negative 4. So I'm going to have negative 4 plus 1. I'm going to have x raised to the negative 4 plus 1 will give me something like x to the minus 3 over negative 3. Okay. Which final answer is going to be something like 1 over negative 1 over x to the 3rd plus c. And this last one here is an exponent, and I have my a and my b. So when I write this one, I'm going to have b over a. So I'm just going to have I4 over 1 e to the a. In this case, a is 4 plus c, which is just going to be 4e to the 4x plus c. That one there. Okay. And that one, there's that one there. I use that rule to get rid of it. So all I did was use the rule up here at the top of the page to find it. Use that one or use that one when I recognize the form. So it's helpful to know the formulas. You know the formulas, you can recognize the form and know your approach. Here's some more. So I recognize the pattern, so I know what rule I'm going to use. So I let my b be equal to 1 and my a is equal to negative 3. So I'm going to have 1 over negative 3 e to the ax. In this case, a is negative 3x plus c. The next one there, my a is 1. My a is 1/2, and my b is 1. So when I put this in, I'm gonna have b over a. I'm gonna have 1 over 1/2 e to the a, which is 1/2, plus c. Make that look pretty. So I have 2e to the 1/2 x plus c. And that's my final answer there, that one. Some more properties of antidifferentiation. What this says here is that simply, sometimes it's easier to simplify it. You can factor out a constant, okay, and then integrate. It'll save you some steps, because with the constant in there, it looks like with the constant in there, it saves you some steps. Okay. And then you can also integrate it by parts of a function. You have a composite function here, f of x plus g of x. You can integrate the first part plus or minus the integration of the second part. And here's another example here. So before I integrate this one, I divide it up into parts. So I break this up into pieces. That's one piece. That's another piece. And that's another piece. And then I integrate. X to the 5th integrates to x to the 6th times 1/6. X squared integrates to x to the 3rd over 3. And dx integrates to x. On the outside I have an 8. Then I factor out the constants, then I integrate. And I put it back together for my final answer here. Now for this next one here, I break it up into pieces, rewrite it there. So I divide everything through by x. There, there, and there. And it simplifies. It simplifies here. There's your result. Okay, so I have my constants on the outside. Here, here, and here. Then I integrate. 1 over x is going to be ln x. Dx will be x. And x to the 3rd will be x to the 4th over 4. And I have my constants. Multiply them back in, and there's my final answer. You can see that's what they did there. They broke it up into pieces. Then they simplified it. Then integrated by pieces here. Forget the final answer. Okay. Now they want us to find a function f such that f prime is equal to x squared, and when f of -1 is equal to 2. So in this case here, the first thing we do is we integrate x squared. So I integrate x squared here. And then I get my function back. Then I evaluate it. When x is -1. Okay. I want to find out what the constant is going to be. So I'm given some initial conditions here. And we're given that f of -1 is 2. And I put in for my x -1, and it simplifies. So I end up with 2/3 2 plus 1/3 is going to be 6 over 3 7/3. That's what my constant of variation is. Then I can plug that back into the original function, and this is my original function here. You can see that's what I did there. Summary. Okay. Antiderivative of functions is a set of functions with with a big function here is they're the inverses of each other. Gives you back the original function of the opposite of the derivative. Okay. Antiderivative is denoted by the symbol of this symbol here. You can check it by taking the derivative of it to see if you got it right. If your integration is correct. And these are some rules here. It's helpful to know these rules so that if you know them like the back of your hand, it'll speed up the process. Then if you have to go back and look to see what the rule is every time. And on the test, you want to know these rules like the back of your hand.